This video has to do with pages 4, the bottom of page 4 through 6 of your chapter 8 notes packet. It's lesson 8.3, where we're talking about zero and negative exponents. On the bottom of page 4, they give you some definitions. It's very important that you realize a to the 0 power is always 1, no matter what a is. A to a negative power is 1 over a to that positive power, and then the reciprocal works as well. I've gone ahead and written down some things that you might want to jot down in your notes, just kind of showing you why this makes sense. If we think about 2 squared, 2 to the first, 2 to the 0, if I go between them, I'm always dividing by 2. So if I use this pattern of going from 2 cubed is 8, divided by 2 is 4, etc., I can see how 2 to the 0 seems to be 1, and 2 to the negative 1 is 1/2, 2 to the negative 2 is 1/4, etc. Another way to think about it is using your rules that we had for quotients. So 1 is equivalent to any number over itself, so I just picked 2 over 2. I can think of these as the power of 2 to the first power divided by 2 to the first power. I can use my exponent rules and subtract the exponents. 1 minus 1 is 0. So hence 2 to the 0 power is 1. So pause the video, jot that stuff down, and then go to the next page. Okay, continuing on page 5. Now I'm going to use my definitions. So I know that 1, anything to the negative power is the same thing as 1 over that something to a positive power. And then I'm going to evaluate the numbers. 3 squared is 9. So this is equivalent to 1/9. On the next one, anything. Okay, the base here is -7, but anything to the 0 power is 1. So that answer is just 1. On this one, I can use the negative thing. So I could go 1 over, because I'm going to put this fraction in the denominator. Okay, that's using my negative rules. And then I'm going to use my power rules. So I know this is the same thing as 1 squared over 5 squared, which is the same thing as 1 over 25. And hopefully we're comfortable dividing fractions. 1 divided by 1/25, okay, is the same thing as 1 times 25. So that just equals 25. Okay, when you show your work, you could go right from here to here. But in case fractions are not your friend, I'm just reminding you. Okay, and then there's one more problem. I have 0 to a negative power. Okay, I define that as 1 over 0 to the positive power. 0 to the 5th power is just 0. Well, I can't divide by 0, so in this case, it's undefined. Okay? So now what we're going to do is some harder examples, and we're going to use these rules and definitions as well as the properties that we learned before in 8.1 and 8.2. There typically are multiple ways to solve a problem. I'm going to show you 2 different ways on each of these, and it doesn't matter which way you do it, whatever makes sense to you. Okay, so these notes are going to be a little long because I just want to show you this, and then you'll be able to practice on other problems on your own. Okay, so the same base, so I know from before that I could just add these, and I would get 6 to the 0 is equal to 1. Okay, that's one way to do it. Another way to do it is I can use what I know about negative exponents. So I could say 1 to the 6 to the 4th times 6 to the 4th. Multiplying fractions, that's just 6 to the 4th over 6 to the 4th. I should know right there that that's equal to 1 because it's the numerator and denominator are the same. If I don't, I could keep using my exponent rules and subtract, and sure enough, I still get 1. Okay. The next one, I tend to deal with the parentheses first. So I would be likely to go that this is 4 to the negative 2 times 2, which is 4 to the negative 4th, which is 1 over 4 to the 4th, which is 1 over 256. Okay? Or you could think of it using the negatives. So this could be the same thing as 1 over 4 squared, all squared. Use my power rules, 1 squared over 4 to the 4th, and 1 squared is 1, 4 to the 4th is 256. Okay, so again, whichever way makes sense to you is fine as long as you're using your exponent rules, as long as you're showing me some work. Please do not just go from here to here. That's where you're going to make a lot of mistakes. Okay, the next one, this is one of the definitions. So this is just the same thing as 3 to the 4th, which is 81. Okay, or I could have, if I hadn't realized that, I could have written it using my negative exponent rules. And then remember, I'm dividing fractions, so 1 divided by 1 over 3 to the 4th. I should realize that just equals 3 to the 4th, which is 81. Okay, and one more on this page. I can use my quotient rules. So -1 minus 2 is 5 to the negative 3, which is 1 over 5 cubed, which is 1 over 125. Or I could have used my definition. Okay, so I have 1 over 5 to the negative 1 goes in the bottom because it was a negative exponent, so it becomes a positive in the bottom. And now I have that, so that becomes this, which becomes 1 over 125. Okay, so pause the video, take a look at all that, try to absorb it, try to understand both ways, and ultimately you can decide which way makes sense to you. So pause the video, and then once you're ready, move on to the next page. Okay, my suggestion when they get more complicated is to first simplify the parentheses and then deal with the negative exponents, make them positive by rearranging them, and then use your rules. Again, that's just a suggestion. You can do any exponent rules that work, but that's not how I'm going to show it. I found that typically that results in fewer errors. Okay, so this whole thing is raised to the 3rd power. So I have 2 cubed, x cubed, y to the negative 15th. As soon as I see that negative sign, I know I'm going to make a fraction because that needs to go on the denominator. These were positive, so they're going to stay in the numerator. And now I'm going to simplify. Can I simplify anything? I only have one x term, one y term. Oh, I have numbers. I know what 2 cubed is, so I can write that as 8x cubed, all divided by y to the 15th. Okay, and your answer should be written as one fraction, one simplified fraction. That is your answer. Okay, let's try the next one. Again, I see an exponent, or sorry, I see parentheses. I see lots of exponents. So I'm going to go ahead and do the exponent part. Okay, and then I'm going to just write everything else out. Okay, now I like to deal with the negative. Okay, these are negative exponents, so they're going to end up, these terms are going to end up down in the denominator, but positive. So the y to the 5th is going to stay on top, but this 2 to the negative 2 becomes 2 squared on the bottom. X to the negative 2 becomes x squared on the bottom. Because again, realize this is the same thing as 1 over 2 squared and 1 over x squared. I still have these values that were on the bottom. They were all positive exponents, so I'm not doing any reversing. Now I can do some simplifying. I know that 2 squared is 4. Okay, I also have this negative 4 I'm going to have to multiply. I have x squared and x squared, so that's x to the 4th, and I have y squared. Now I have y to the 5th. 4 times negative 4 is negative 16, x to the 4th, y squared. Am I done? No, I'm not done, okay, because I have 2 y terms. I need to deal with that. So y to the 5th, I have y times y times y 5 times. I only have y times y 2 times here. If I subtract, 5 minus 2 is 3. So I have y cubed on the top, and I have negative 16 x to the 4th on the bottom. The negative sign can be on the top or the bottom. I just kept it kind of where it was in my problem, but it would be equivalent as long as you only have one negative sign in the whole problem. Okay, so why don't you pause the video and try the next one. Use pencil though in case you have to erase, and then check back and see how you did. Okay, let's take a look. You should have ended up with 3x to the 12th, y to the 5th, all divided by 4. If you didn't get that, let's take a look piece by piece. Okay, again, my suggestion is dealing with the parentheses. So I first raised everything to the power of 2 on the bottom. Next, I deal with my negative exponents. I know my definition that says a negative exponent is the same thing as 1 over the positive, So basically I can flip positions and make it positive. So I look in the numerator. 12 is not raised to a negative exponent, so it stays. X to the 8th is positive, so it stays. But y to the negative 7th, I'm going to move down and make positive. Y to the 7th ends up in the denominator. Then I look at the denominator. 4 squared, that's a positive exponent. I keep it. X to the negative 4th, that's a negative exponent, so it's going to move up and become positive exponent. Same thing with y to the 12th. Now I can combine my x's. I get x to the 12th up top. I see I have two y's. Y to the 12th minus y to the 7th is y to the 5th. I have more y's on top. The y to the 5th stays on top. And then almost looks like I'm done, but I need to remember that 12/16, this is just a normal fraction. I can simplify that, so I want to write it as 3/4. Okay, and again, answers should be written as one simplified fraction. So this is what you should be looking at. Sometimes you see like 3/4 in front and then x 12th y to the 5th, but in general, that's not the preferred method. So I would like you to always write it as a simplified fraction and keep it in fractional form like that. I think it'll be less confusing for you. Okay, so we now just have some thought questions here. We want to see, is this true? If it's not true, we're going to come up with an example. So I'm going to just take this and simplify it. So a to the negative 3 divided by a to the negative 4. I know from my rules that that's the same thing as a to the 4th over a to the 3rd, swapping positions. And then 4 minus 3 is just a to the 1st, or a. Well, a is not equal to 1 over a. So this is false. It asked me to prove that using another example. So let's just take 2 to the negative 3rd power and 2 to the negative 4th power. That's the same thing as 2 cubed. Oops, sorry, not 2 cubed. 2 to the 4th over 2 cubed. Switching it. 2 to the 4th over 2 cubed. I can subtract, so that's the same thing as 2 to the 1st power, or 2, and 2 is not equal to 1/2. Okay, let's look at this one. A to the negative 1 over b to the negative 1. That's the same thing as b to the 1st over a to the 1st, which is just b over a. B over a does equal b over a, so this one is true. And lastly, one more. Okay, a to the negative 1 plus b to the negative 1. That's the same thing as 1 over a to the 1st plus 1 over b to the 1st, which is just 1 over a plus 1 over b. That's not equal to 1 over a plus b. If you came up with common denominators, that would be the same thing as b plus a over ab. Okay, it is not equivalent. So this is a false. And lastly, let's just do an example using numbers. So let's do 2 to the negative 1st plus 3 to the negative 1st. That's the same thing as 1 over 2 plus 1 over 3. 1/2 plus 1/3, getting common denominators, is 3/6 plus 2/6. That's 5/6. Okay, and then 1 over a plus b would be 1 over 2 plus 3. 1 over 5 is not equal to 5/6. So sure enough, that is false. Okay, these notes are a little bit long, but hopefully we'll get lots of practice and this will start making sense. Thank you.